Hello everyone and welcome to day 1 of 30 days DSA challenge, where we will be solving a DSA problem every day for the next 30 days. So this is day 1 where we will solve a easy level question of the topic array, and the name of the question is twosome. Now you can find the link of this question in the description, and you can also download this Excel sheet from the description as well. So now without wasting much time, let's see what the question is. So this is the question on LeetCode. Now let's say what our question says. That the question says that we have given an array of integers nums and target and an integer target. Return the indices of the two numbers such that they add up to target. So basically our question is saying that we have given an integer array named as num, and we have also given an integer, and we have also given an integer variable named as target. Now we have to return the indexes, right? Very importantly, we have to return the indexes of the two elements, and the sum of those elements should be equal to our target. So this is the question, quite simple. Now let's see what it is written ahead. So you may assume that each input would have exactly one solution. So this is very important. So the question says that you may assume that every input, like for every input, we have exactly one solution. We cannot have any input for which we have more than one solutions, right? And you may not use the same element twice. So the second point is also very important. We cannot use a same element twice, right, in our answer. You can return the answer in any order, okay? And these are some sample test cases. So let me just explain you the 2 points which were very important and which were mentioned there. So the very first point was okay, let me just write properly. For every test case, right? For every test case, or you can say that for every input, right, we will have exactly one solution, right? This is very important. For every input, we will have exactly one solution. We cannot have more than one solution for any particular input, for any particular test case. How? So let's take an example. Let's say that we have an array named as nums, and the elements are 5, 2, 6 and 1, and our target is equal to 7. Now if I ask you, return me the indexes of the two elements whose sum is equal to 7, right? So before that, let me just write the indexes. Okay, so these are the indexes. Now if we take this 5 and this 2 and we add it up, we'll get 7, which is equal to my target, correct? And what are the indexes of this 5 and 2? The index of 5 is 0 and the index of 2 is 1, correct? So this can be our possible answer, right? Okay, but at the same point, if I take this 6 and this 1, right, and if I add it up, I'll get 7, and this 7 is also equal to my target, right? And what are the indexes of 6 and 7? The index of 6 is 2 and the index of 1 is 3. So this can also be my possible answer. So now question says that you in every input, for every test case, you will have exactly, right, exactly one solution, right? So this particular input is invalid, right? In this particular question, we will not have any input which gives us more than one answer, right? Now the second point in that question was that we can use one element only once, right? Or in the other words, we can say that we can use one element. In the other words, we can say that we cannot or can't use one element twice, correct? We cannot use one single element twice for computing our sum. So again, let's understand this with another example. So let's say we have one input array such as 5 and 2 and again 5. Okay, so this is a nums array, and let's say that our target is equal to 7, right? And the indexes are 0, 1 and 2. Now if I again ask you, give me the two elements, give me the indexes of the two elements whose sum is equal to 7, so you can say that, sir, we can take this 5 and we can take this 2, right? So 5 plus 2 will be equal to 7, correct? And what are the indexes of this 5 and 2? The index is 0, the index is 1. So this can be my answer, right? This can be my answer. But some of you might say, let's do something else. Let's take this 2 and let's take this 5, right? Let's take this 2 and let's take this 5 and let's sum it up. So our answer is 7, which is equal to our target. Now the indexes of these 2 and this 5 is 1 and 2, correct? So this can also possibly my answer, right? So this is again one invalid case. Why invalid case? Because we took this 2 times, right? We used it twicely. How? So firstly, for our first answer, we took this 2 and this 5 and we sum it up and we got 7, right? And then we said that our answer can be 0 and 1. Okay. But second time what we did, we took this 2 and this 5. Now my answer would be 1 and 2, correct? Would be 1 and 2. So what I'm trying to explain you is we cannot use one element twice. We cannot use any element twice. Here we have used this 2. We have used this 2 times, right? We have used this 2 times. So we cannot do that. And again, if you see that we are getting kind of two possible answers for this particular test case, right? So if I again write it 5, 2 and 5 and the indexes are 0, 1 and 2, so some of you might say that the answer can be 0 or 1 and the answer can be 1 or 2 as well. So again, in this particular test case, we are getting two solutions, which is not possible. So again, this is one invalid case, right? This is one invalid case. Now let's take another example. Let's say we have 5, 2, 6 and 3 and my target is equal to 7. Let me write the indexes. These are the indexes. Now if I say give me the two numbers which sum up to give me target equal to 7, you will say, sir, if we add up 5 and 2 we will get 7. This is equal to my target. This will equal to my target. But so let's say, okay, let's say that what will be the answer? What will be the answer? You will say answer will be the index, right? Index. So it will be 0 or 1. But what if some of you might say that instead of adding 5 with 2, let me write it like this, 2 and 5. It again gives me 7, which is equal to my target. And now if I think about the indexes of 2 and 5, now my index will be 1 and 0. Now what I have to return? Should I return 0 or 1 or should I return 1 and 0? So if you had read the question properly, then question says that you can return your answer in any order, right? This is again very important. You can return your answer in any particular order. So I hope these 3 points are equal to you. Sorry, these 3 points are clear to you. Now let's take one test case and let's try to analyze. So the test case is 2, 7, 11, 15 and the target is 9. So we have 2, 7, 11, 15 and our target is equal to 9. The indexes are 0, 1, 2 and 3. Now if I again ask you, give me the indexes of the two elements whose sum is equal to 9, you will say we can add 2 and 7, which will give us target equal to 9 and their indexes are 0 and 1. So we can either return 0 or 1 or we can return 1 and 0. I say okay, this is good. Let's analyze. And the test case, this is 3, 2, 4 and the target is 6. Okay, so we have 3, 2, 4 and our target is 6, right? Again, if I ask you, give me the index of the two elements, so sum is equal to 7, you will say we can add up 2 and 4, we will get sum equal to 6, which is equal to my target. So I can return either 1 and 2, or I can return 2 and 1. Both of this are valid, right? And if you see the question, we have to return a vector, right? We have to return a vector. So that's another point, right? We have to return a vector. Okay, so I hope now the question is quite clear to you, and let's now try to find out the solution, right? Let's try to find out the solution. So let me just take same input. Let's say we have 2, 11, 15 and 7, correct? Instead of this, let's say that we have another element 1, right? And let's say now my target is equal to 9. Okay, let me just write it again. My target is equal to 9. So what we want, right? What we want? We basically want two elements, right? We want two elements, and the sum of those two elements should be equal to my target. So what possibly I can do is I can try the combination, right? I can try the combination of all two elements, right? I can try the combination of all two elements, and I will try to find out their sum. If their sum is equal to my target, then I will return the indexes, right? So what I mean by combination of all two elements, so let's say, let me just write the index here. So what I can do, I just need to find out the combination of all the two elements. So I can say, I can take 1 and 2, correct? I can take this one and this 2. I can also take this one. I can also take this one and this 11, correct? This is also a combination. Or what I can do, I can take this one and I can also take this 15. This is also a particular like combination of two elements. I can take this one and I can take this 7 as well. So I can say 1 and 7. So these are the possible combinations, and then I will try to find out the sum of these elements, right? So let me just do a quick dry run to make you understand this approach. Okay, so let me just drag it down. Okay, so let me just erase it. So what we'll do, we will try to find out the combination of two elements, all the possible combination of the two elements, and we will make sure that the sum should be equal to target. If the sum is equal to target, right? If the sum is equal to target, then we will return the indexes, right? So let's say we take this one, we will take this one, and then we will combine this one with all the other elements which are ahead of 1, right? So we can take this one and we can take this 2, right? Then we can take this one and we can take 11. Then we can take this one and take 15. Then I can take this one and I can take 17. Now next what I will do, I will compute the sum of all these two elements, right? The sum is equal to 2. The sum is equal to 3. Is it equal to my target? You will say no. Sum is equal to 12. Is it equal to my target? You will say no. Sum is equal to 16. Is it equal to my target? You will say again no. Now the sum is equal to 8. Is it equal to my target? You will say no. So we did not found any answer. Okay, no problem. No problem. We will again try to find out the other combinations, right? So now instead of taking 1, I will take 2, and then I will try to combine these 2 with all the other elements which are ahead of 2, right? So I'll take 2 and 11, and then I will take 2 and 15, and then I will take 2 and 7, right? Now what I'll do, now I will try to compute the sum. Sum is equal to 13. Is it equal to 9? No. The sum is equal to 17. Is it equal to 9? No. The sum is equal to 9. The sum is equal to 9. And is this 9 is equal to my target? You will say yes, it is equal to my target. Now if it is equal to my target, what I'll do, I'll just return the indexes. The indexes are 1 and 4, and this is my answer. So now I hope that the intuition, the idea to solve this question is clear into your head, right? Now if you are thinking why I am like, when I said I'll take this 2 and I said I will try to combine this 2 with all the elements which are ahead of 2. Now you might ask me a question that why we are combining 2 with only elements which are ahead of 2, why we are not combining 2 with 1 as well, why? So the answer of this question is, when we were computing sum, when we were trying to find out the combination of all the elements with 1, then we would have computed 1 and 2, right? Then we would have computed 1 and 2. Now if this 1 and 2 would have equal to my target, then I would have returned the index, correct? I think this much is clear. Now when I am at this point, when I am at 2 and I'm trying to find out all the combinations of the 2, and if I again take this 1, if I take this 1, then what will be my combination? My combination will again be 1 and 2. My combination will again be equal to 1 and 2. So kind of we are doing a repetition, right? We are doing a repetition which we do not want to do, right? Which we do not want to do, because if my 1 and 2 would have resulted to a sum equal to my target, then I would have returned 1 and 2 at that particular moment, right? At that particular moment itself. Okay, so I hope this is clear to you. Now let's just try to write the pseudocode. Pseudocode is going to be very easy. So firstly, we will have a vector, let's name it as answer, right? And then we will have n, which will be equal to the size of our nums array, correct? Then what we'll do, we will run a loop, let's say I equal to 0 up to lesser than n, correct? Up to lesser than n. Then what we'll do, we will create a temporary sum, right? And this sum will have the value of num of I, and then again we will make a loop. Now let's say this is j is equal to I plus 1, and j should be lesser than n, and we will check if this temp sum plus the element which is present at this particular index at j. So temp sum plus ARR of j, not ARR of j, num or nums of j, if it is equal to my target, then what I need to do is just put the indexes into my answer. So I'll say that answer dot push back I, and then I will write answer dot push back j, and then I will return my answer at this particular time, at this particular instance. Now why I am returning my answer? Because we know that we will have exactly one solution. We will have exactly one solution, and if I had found my solution, just return it. Just return it. I do not need to check it again for the next solution, right? So this is the particular code. If you want to dry run, you can dry run as well. So let me just give you a quick dry run of this, right? Let me just give you a quick dry run. So let's say that our input is 2, 11, 15 and 7, correct? Okay, let me just write 0 as well. And our target is equal to 9, right? So these are the indexes. Now initially my I will be at this point, and in my temp sum, so you can see that temp sum is equal to nums of I, right? So I is at 0, so the element present at the index 0 is 0, so that now temp sum is equal to 0. Now my j is at this particular index, right? J is at this particular index because we know that j is equal to I plus 1, correct? So now we will add it. So we'll write 0, this is my temp sum, and now I'll add 2. Is it equal to my 9? You will say no, this is not equal to my 9. Okay, no issues, just increment your j, right? Just increment your j. So now j is here. We will again do 0 plus 11. Is it equal to 9? You will say no. Okay, again just increment j. So now my j is at index 15. So we'll write 0 plus 15 because 15 is the element which is present at this particular index. It is equal to 15. Now is it equal to my target? You will say no. Okay, so again just increment your j. Now my j is here at index number 4. So we'll write 0, which is my temp sum, that is temporary sum, plus the element present at the index number j. So the element present at index number j is 7. 0 plus 7 is equal to 7. Is it equal to my target? My target is 9. Now here my sum is 7, they are not same again. So this is not my answer. Correct. So now this inner loop, let me just rub it off. Okay, so now this inner loop is completed, right? This inner loop is completed. Now what will happen? The I will go to the next index, right? Now the I will go to this index. Okay, and now my j will be at the index number 2 and I will be at index number 1, right? And initially my temp sum will have value as 2, correct? Then what I'll do, I'll do temp sum plus the element which is present at the index j. So we'll write 2 plus 11. What is it? It is equal to 13. It is equal to 9. Is it equal to my target? Is it equal to my 9? You will say no. Okay, then my j will go at this index number 3. Then we will plus 2 and 15. We will get 17. Is it equal to my target? You will say no. Now the j will move to index number 4. Here we have 2 and the element present at index 4 is 7. 7 plus 2 is equal to 9. Is 8 equal to my target? Is 8 equal to my target? You will say yes, this is equal to my target. If this is equal to my target, just return the value of I and return the value of j. So the value of I is 1 and the value of j is 4. This will be my answer. So I hope this is clear to you. This particular approach is clear to you. And before coding, let me just clear the time complexity. The time complexity is O of n square because we are basically using 2 for loops, and the space complexity is O of 1 because we are not using any additional space. Now without wasting much time, let's go to LeetCode and let me just write the solution. So the code is going to be very easy. We will basically have a vector of int named as answer, which will hold our answer. And let me just write int n is equal to nums dot size, and then we will just run a for loop. Int I is equal to 0, I is lesser than n, and then I plus plus. Then we will have one variable named as int target. So not target, let's name it as int temp sum, that is temporary sum, is equal to nums of I. And then we will have another loop, that is int j is equal to I plus 1, j is lesser than n, and then j plus plus. Again we will check if the temp sum plus the element which is present at the index j, if it is equal to my target, then what I will do, I'll push it into my answer array. So I'll write answer dot push back I, and then I'll write answer dot push back j, and then I will return my answer. Why I am returning my answer? Because I know that we will have exactly one solution for every input. Right, so our code is completed. So as you can see that it is like the function toSum returns a vector, right? So therefore at the end we need to return our answer vector as well, else we will get one error. But we know that for every particular input we will have exactly one solution. So at one particular instance our code will come at the line number 19 and it will return our answer, but still I am returning our answer here at line number 23, because if I just comment out and run, then you can see that we will get one error, right? For sure we will get one error. See, this is the error that non-void function does not return a value in all control paths, right? So it is important to return a value because as it is a non-void function. So let me just run it by returning a value at the end as well. Okay, so you can see that all the test cases are passed. So let me just submit it. Okay, so you can see that this particular solution is accepted. So now let's try to think, can we optimize this solution? So when I'm saying can we optimize, what does it mean? It means that can we boil down this time complexity to something lesser than O of n square? Can we boil down this time complexity to O of n? So the answer is yes. Yes, we can definitely do that. And for that particular approach, we will use HashMap, right? We will use HashMap, and I hope most of you are aware with this particular data structure. So for explaining this particular approach, I will use the same example, that is 2, 1, 11, 15 and 7. Okay, so let me write it again. It is 2 I just forgot, let me just see it again. It is, okay, 1 to 11, 15 and 7. So we have 1, 2, 11, 15 and 7, correct? And my target is equal to 9, right? And let me just write the indexes are 0, 1, 2, 3 and 4, correct? So for this particular approach, we will use a very basic mathematical concept, that is, let's say we have two numbers A and B. If I sum up these two numbers, I get the sum equal to target, right? Now if I ask you, you know the value of A, you know the value of target, can you find out the value of B? You will say yes, it is very easy. We just need to write B is equal to target minus A. Now this is the particular formula, or you can say this is the particular concept which we will use in solving this particular problem. Okay, so firstly we know that we will use a hash map. So let me just create one hash map. Okay, let me just change the color. So this is our map. Our hash map will store two things. Very firstly, the element of the array and the index at which that particular element is present, correct? So let me just rub all these things, and then we will see how we can solve this problem with this particular approach. Okay, and what we will do, we will run a for loop from I is equal to 0 up to n, correct? Now at every particular index, we will check that if my target minus nums of I, if this particular thing is present in my map or not, right? We will check if it is present in my map or not, right? If it is not present, right? So let me just rub it, right? If it is not present, if not, then what we will do, we will put that element, in map with its index. Okay, so this is something which we are going to do. So let's say initially my I was at index number 0. So nums of I is equal to 1 and my target is equal to 9. We did 9 minus 1, which is equal to 8. We'll check, is 8 is present into my map? You will say no, initially my map is empty, it is not present. If not, then what we have to do? Put that element in the map with its index. So we'll put that element. What is the element? Element is 1. We will put the element 1. What is the index of this element? Index is 0. So we'll put 1 and 0. Correct? Okay. So now my index, now my I will move to the next index, that is index number 1. Now what is the value present at index number 1? The value present at index number 1 is 2. We will subtract this 2 with 9. So 9 minus 2 is equal to 7. We will check, is this 7 present into my map? You will say no, it is not present. If it is not present, what we have to do? We have to put that element in the map with its index. So we'll put 2 and the index of 2 is 1. Okay. So now again the I will move forward. Now this I will come to this particular index number 2, and now the value present as index number 2 is 11. So we'll do 9 minus 11, which will be equal to minus 2. And is this present into my map? You will say no, it is not present. So if it is not present, what we have to do? We have to put that element into map with its index. So the element is 11 and the index number is 2. Again our I will move forward. Now the I is at index number 3. So the element present at index number 3 is 15, right? So we will just subtract 9 from 15. So 9 minus 15 is what? So the answer the answer will be -6. Now, is -6 is present into my map? No, it is not. So what we will do, we will push this element with its index into my map. So the element is 15 and the index is 3. Correct? Okay. Very good. Now what we will do, we will again move our I. So now my I will come at this index number 4, and now the element present as index number 4 is 7. So I'll do 9 minus 7, and 9 minus 7 will give me 2. Now this is the point where you will understand. We will check, is this 2 is present into my map? You will say yes, this 2 is present into my map at index number 1. What does it mean? It means that this number, this is 7, and this 2, if I add this 7 plus 7 and 2, I will get my target, I will get my sum equal to 9, right? If I add 7 plus 2, I will get it equal to 9, and this 9 is my target, right? So now what we just need to do, we just need to return the indexes, correct? So firstly, what is the index of 7? Index of 7 will be I, so I is pointing to 4. So we'll return 4. And what is the index of the 2? We will get the index of the 2 from our map. So from here we can see that the index of 2 is 1. So 4 and 1. So we'll simply return 4 and 1. Correct. So I hope this particular approach is clear into your mind, right? And now let me just write the pseudo code. So we will create a map. I'm creating an unordered map with integer and integer. Let me name this as MP. And then we will have a vector of int as answer, and we will just run a single loop, I is equal to 0 up to n. Correct. Then what we need to do, firstly we will compute target minus num of I or nums of I, whatever it is, whatever the input is, nums of I, and we will just store it into a temporary variable known as temp. Now we will check if map.find temp is not equal to mp.end. So what does it basically means? It will check that if this temp is not present, right? If this temp is not present, so sorry, if this temp is present into my map, so it will not be equal to map.end, right? It will not be equal to map.end. These are very basic. I hope you are you know about these things. Okay, so if this is the case, what we'll do, we'll just write answer dot pushback I, and then we will write answer dot pushback map of temp. Correct. This is back. This map of temp will give me the index, right? This will give me the index of this temp. Okay, and then I can just break out, or I can also return. So I'll just write break. Correct. So now think of if that particular, like if this temp is not present into my map, then what we do? Else we just put that element into my map with its index. So we'll write mp map of nums of I is equal to I. Just put that particular index, and then at the end we will return our answer, right? We will return our answer. So this is the second approach. So now we are back at LeetCode. So let's just code it up fastly. So let me just remove it. We know that we will have an unordered map which will have two values, int and int type, right? It will store two values. First is the element itself, and second the index of that particular element. And then we will run a loop from 0 lesser than n, right? So we will just have a temporary variable known as int temp, which will be equal to my target minus nums of I. And now we will check if map.find temp, if it is not equal to map.end. This particular means that this particular temporary variable is present into my map. So if this is the case, then we'll write answer dot push back I, and then we will write answer dot push back MP of temp, and after this we can just break out, right? Then we can break out. Now if that element is not present, if this temporary variable is not present into my map, then what I simply do, I just simply push that particular element into my map with the index, right? So I'll write map of nums of I equal to I. Okay, so this is the code. Let me just run and let's see we are getting the correct answer or not, correct output or not. Okay, so I think we have some error. So yeah, the spelling of target is wrong. Now let me again run it. Okay, so now you can see that it is accepting, it is running fine for all the 3 test cases. Let me just submit it. Okay, so now we can say that we can see that it is accepted. So now let's try to analyze the time complexity and the space complexity for this particular solution. So we know that for space complexity it is O of n. Why it is O of n? Because we are using a map, or we are using an unordered map data structure, correct? And the space of this vector will be constant, right? Why? Because it will only have 2 elements, right? So we can say that the space is constant for this particular vector, right? So now we know that if we talk about the time complexity, then this particular for loop is running for O of n times, and what we have used in our solution, we have used an unordered let me just write it again in a better way. We have used unordered map, correct? We have used an unordered map. So for this unordered map, we it is important for us to know that we are doing this. So we are just putting element into our map, right? We are putting element into our map, and then here we are running the dot find method in map. So when we talk about the unordered map, then the average time complexity of all the operations in an unordered map is O of 1, right? So if we consider the average time complexity for the unordered map, then the overall time complexity will be O of n for this particular solution, and the overall space complexity will be again O of n for this particular solution. I hope you understand this. So this for loop will run for O of n times. This will take O of 1, right? This will also take O of 1 time complexity. So the overall time and space complexity will be O of n and O of n. So I hope you had understood this particular problem. Now we will meet tomorrow with a new question. Thank you for watching.